sulfuric acid rain. The two small planets closest to the Sun, Mercury and Venus. Join us for a virtual reality flight across their surfaces. Our beautiful blue and fragile Earth seen from space. The satellite pictures of our world which show the changes through the seasons and the environmental damage we have caused. All in Encyclopedia Galactica. Orbiting closest to the Sun, Mercury, Venus, Earth and Mars, the four rocky midgets of the inner solar system. Bathed in warmth and sunlight, they're solid little planets with hard-baked crusts. The outer planets, except for Pluto, are giant spheres of gas, chilled in twilight. From Earth, by far the brightest planet is the rocky midget Venus. Over a season, Venus and Mercury skip through the sky close to the horizon. In fact, the view is of their tight solar orbits, best seen at dusk or dawn. Mercury on the right barely clears the skyline. Nearest the Sun, it's hardest to see. Venus takes 224 days to orbit the Sun. Tiny Mercury, just 88. At less than 70 million kilometers from the Sun, Mercury is perpetually scorched and irradiated. These pictures from the early 70s were radioed from the space probe Mariner 10. They reveal a surface pocked with craters, barren and still. Temperature by day, 460 Celsius. By night, minus 170. Gravity, 1/3 of Earth's, and no atmosphere. A cracked and battered little world. But why so many impact craters? The answer is the Sun. Its powerful gravity draws in debris from space. With Mercury in line of fire, it takes a lot of hits. Mercury's surface is like the hidden side of our moon. Both have great circular basins. Indeed, Mercury isn't much bigger than the moon. The planet Venus is altogether bigger. Almost Earth's twin in size and density, but completely veiled in swirling cloud. Not until a series of Soviet missions was the truth to be known. The object was to penetrate the Venusian fog and soft land on the surface. It was a descent into hell, atmosphere 90 times heavier than Earth, temperatures to melt lead, visibility just 3 kilometers. To this day, these are the only photographs of the surface. They were zipped to Earth before the lander cameras frazzled. The rock was basalt, probably fractured slabs of volcanic lava. Radar was to provide a better picture. Orbiting mappers electronically stripped the clouds to give the first wide-angled images of Venus, and volcanism was confirmed. But this was a flatter planet than expected. There were few craters and less contour than on Earth or Mercury. The impression was of an ocean bed, smoothed by the motion of currents. And radar had more delights. The globe without cloud, and in reverse rotation to all other planets. and radar let us fly. This is the topography of Venus, visualized on computer. Heights are exaggerated and color guessed at, but otherwise the features are accurate. The animation has been meticulously rendered from a global portrait compiled by Radar Mapper, a montage of thousands of radio snapshots through the clouds, like the echo soundings of a ship at sea. It works like this. As the mapper orbits, thousands of pulses a second are bounced to the surface. They sense details as small as 100 meters. In each 3-hour orbit, the mapper records a swathe of information 20 kilometers wide. In less than 250 days, most of the planet can be swept, the data ready for computer animators on Earth. Thus, in the 1990s, has the American craft Magellan been brilliantly at work. A Magellan image of volcanoes and fractures. A sinuous channel, possibly a lava flow. Fold mountains called Freya. A corona. Remember, these are radar images, not photographs. Cleopatra, a double-ring crater. The Acna Range with an asteroid crater. Volcanic extrusions like mushrooms. Crater Golubkina, 34 kilometers across. And the Dickinson crater, first as a still, and now in animation, one of a trio, as we skim the Atlanta plain of the Northern Hemisphere. Most of the planet is rolling uplands. The two largest regions are like continents. Ishtar Terra, the size of Australia in the north, Aphrodite Terra, as big as Africa, to the south. Everywhere is evidence of volcanoes, but so far no sign of activity. Venus is the most volcanized planet in the solar system. Magellan discovered linear mountain belts, a feature shared only with Earth. But the scarcity of craters compared to Mercury or Earth's moon suggests a young landscape. It means also a surface shielded from bombardment. All but the biggest cosmic missiles would vaporize in the dense Venus atmosphere. This is like the bottom of the sea. These pancakes are volcanic eruptions squashed by atmospheric pressure. Such formations can be found in the depths of oceans on Earth. Magellan's imagery cannot convey the hell of Venus, a crushing, poisonous atmosphere of carbon dioxide, clouds of sulfuric acid, temperature 450 Celsius. This is the more likely scene, an inferno where light is bent and heat has no escape, the ultimate greenhouse effect, plus non-stop thunderclaps. Were this photography instead of radar animation, we'd see sulfuric acid clouds reacting with this volcanic peak. Venus is weird. It revolves so slowly that a day is longer than a year. And it's windy. In 4 days, the massive cloud blanket blows right round the planet. Venus resembles a little understood period on Earth. from the time shortly after Earth's crust had cooled to the emergence of life. Why Venus should have remained sterile and tormented is a mystery. Stay with us after the break when we look at our own planet from outer space. From the very first pictures of the Earth rotating to visual evidence of the hole in the ozone layer. The Galileo spacecraft, looping the Moon and Earth. An orbital slingshot to pick up speed for a mission to Jupiter, a detour with a bonus. En route, Galileo had captured the first pictures of Earth in rotation. The date, December 1990. The sun's reflection skims across the Pacific towards Australia. Our blue Earth, third planet from the sun, at a distance of 150 million kilometers, neither too hot nor too cold. The ideal incubator for life. These are satellite pictures, a compilation of thousands of cloudless images which show Earth as never before. Now we see the upper atmosphere, the aerosols of the ozone layer. Here in motion, it's this filter that protects us from solar radiation. During 2,000 million years, plants have changed our atmosphere by breathing oxygen into it. Today, CFC emissions may be changing things again, starting with this hole in the ozone at the South Pole. Earth has a busy atmosphere, 21% oxygen, 78% nitrogen. Without it, there'd be no life. And yet we threaten it by burning fossil fuels and forests. Each year we spew 7 billion tons of carbon dioxide into the air. We are gambling with immense natural forces. The energy in one day of a hurricane would power all industry in the United States for a year. We're at the mercy of our atmosphere. Weather satellites help us understand the atmosphere, the life-sustaining engine that maintains a mean global temperature of 15 degrees Celsius. The wind systems are driven by hot air rising at the equator. Their direction is modified by the spin of the Earth. Carbon dioxide keeps the planet warm by trapping heat. Scientists say we're producing too much carbon dioxide. They worry that it'll cause overheating, threatening a lifeless inferno like Venus. The rotation of Earth means that sunlight falls on only half the planet at any one time. From the surface, the sun appears to move from east to west across the sky. In fact, the sun is still. It's our planet that's moving, a 24-hour rotation causing day and night. This time-lapse through the night has the moon, top left, sinking in the west. And here, the Milky Way and the stars seem to travel through the heavens. Again, it's not the stars that are moving, it's Earth rotating on its axis. Were the axis upright, day and night would be the same the world over, but it's not. Earth is tilted 23.5 degrees from vertical. This varies the length of day and night. Add to that the complication of Earth orbiting the Sun, and there emerges an explanation of the 4 seasons. It takes Earth a year to orbit the Sun. Each day, the angle at which sunlight falls on Earth changes slightly. Over a season, it's quite a lot. In the 6 months from winter to summer, the change is greatest of all. From this position, it's summer in the northern hemisphere. The north has short nights and long days. The equator hardly changes. The south has long nights and short days. From this opposing position, it's winter in the northern hemisphere. Short days and long nights in the north, long summer days and short nights in the south. From Earth, this means the midwinter sun is low in the sky. At midsummer on the same latitude, it's higher. This satellite sequence shows another seasonal change, the northerly advance of vegetation growth as the northern hemisphere tilts towards the sun. In Antarctica, the seasonal ebb and flow of the ice cap. Summer, and now the return of winter. Ten 10,000 years ago, the northern ice cap reached as far south as New York and London. It's uncertain, but such ice ages could be caused by a periodic wobble in Earth's orbit. Satellites monitor global temperature. Currently, we're enjoying an interglacial period. Temperatures are steady, although over the last 100 years, they've risen by 0.9 of a degree Celsius. "71% of Earth is ocean. The rest began as a supercontinent 250 million years ago. Ever since, its component parts have been drifting on plates towards the positions they occupy today. The red dots are volcanoes. They mark cracks where the plates meet, like pieces of a jigsaw. Even now, at a few centimeters a year, the drifting continues. Under the oceans, the plates are either pulling apart or pushing beneath one another. This lava lake is like plates parting. And this like plates subducting. Where plates interact, volcanoes erupt. This is the Mount St. Helens volcano, on the line between the Pacific and the North American plates. A visible reminder of Earth's volatile interior. From above the clouds, the plume of the Mount Pinatubo eruption in the Philippines. Stratospheric pollution that reduced Earth's temperature by 1 degree as volcanic ash girdled the globe. Before Pinatubo, a sunset with stars. Afterwards, a red atmospheric haze. These are the lights of Western Europe, another pollutant that obscures the stars. How clearly we'll see the cosmos in the future depends more on the human factor than occasional volcanic eruptions. Next time in Encyclopedia Galactica, we'll fly you to the moon, how the moon affects us on Earth with computer-generated plans to colonize and exploit its mineral potential. We go back to Mars, the red planet, a cold desert where once there were rivers and perhaps life. And we take you on an exhilarating computer flight over the extinct volcanoes and down the Mariner Valley, 10 times bigger than the Grand Canyon. To the latest plans to return. And the cold red planet, where once there were rivers and perhaps there was life. Prepare yourself for a flight around the planet Mars with a virtual reality spin down the Mariner Valley. All in